Hi, my name is Jess Baker. I'm doing my extra credit project on the patterns in nature, a lecture topic I went to at the beginning of this semester that I found very interesting. I found it really interesting because I love being outdoors and just being immersed in nature because it's all so beautiful. Ever since I was a kid, I just loved being outside, so I've always wanted to learn more about what surrounds me. So a couple of the topics that the professor went over, one was stability, and how stability is key in nature, not optimality. Like a river is not straight, it meanders because it's trying to fill the capacity of the water rather than try to get it where it's going faster, because if it did, then the banks would overflow. It's also self-organized, like there's patterns in everything, like as you can see, a tree and a river delta and a lightning bolt all kind of have the same similar structure where they just branch out from a main source. It can never be fully predicted, but it's a very complex process, but it is self-organized. There's also dynamic equilibrium in nature, like when there's a cause, there's also an effect, and they always balance each other out. Like these sand dunes, when wind blows, the sand gets higher in one place and lower in the other. They just move around with these very interesting grooves in the sand that are all 10 centimeters apart that happens from the wind currents. Another cool thing he talked about was beach cusps. They, as you can see, I'll zoom in a little bit, they have a perfectly, sinusoidal curve. This happens when oncoming waves hit the horn of the beach. The cusp is forced to split into two directions. And then the crashing of the wave slows its velocity, so the waves pick up different weights of sediment. This process continues and the beach cusps grow until their full size has been reached. And then there's these things called Mima mounds that they can't explain why they happen, but there's just a ton of holes in the ground, basically. This is out in, Iowa and that part of the United States. And they have a couple hypotheses why it happens, but nothing has been confirmed. It could have been from seismic activity when the ground shakes. Some of the ground fell through, or there were little pocket gophers, or even just an accumulation of sediments around old clumps of vegetation. Another thing that physicists can't figure out is axial segregation. What happens is when you put two different size mixtures in a rotating cylinder, they eventually kind of sort themselves out in these different blocks, like right here, just after spinning, and they can't explain why. They have small hypotheses, but really don't know why this happens. So after hearing all these things, I wanted to look more into the patterns of nature and found the Fibonacci numbers, which is a series of numbers that are found in nature where the next number is added together from the two preceding numbers. Like this shell, the area of these squares, it follows the Fibonacci numbers, and so does this pattern. So in conclusion, I found this so interesting, and to find out that physicists still don't know everything that's going on in nature is very fascinating. And also just that patterns occur everywhere, not just by human design. So, yeah, I just really enjoyed this talk. Thank you for listening. Bye.